Hello, everyone. I am Diann Brei, and I am the Chair of Integrated Systems and Design, and I want to welcome all of you here today to help us celebrate both the journey that our graduates have just completed and as they embark upon their next journey. Graduates, raise your hand. We are so proud of you. Thank you for coming. Thank you for contributing to our scholarly community. We are very, very glad that you are here on this day. Can you stand? And we would all like to give you a round of applause. Now, did you see how that was done? Because almost all of you at some point will be standing here. As you've gone on this journey, there are a number of people that have supported you along the way. And so we're going to go through the rounds. Are you guys ready to stand? So the first one are the faculty that have been your instructors and your mentors. Anyone that is the faculty, please, and instructor, please stand up. Stand up. Come on. And program directors. Thank you. There's also a large group of people that work behind the scenes to make everything run smoothly and make sure that we all succeed, and that is the staff. All the ISD staff, can you stand up? And let's give you a round of applause. They're all waving back there. We'll wave back there. I also like to honor the GSAC. I think that we have one or two. Can you stand? Back there. They're in the back. These students are our leaders. They are the ones that help us to do workshops, to go out to the students, make sure that the voice is heard, and they put on lots of fun events and make sure that we're all in tune and having a good experience, right? So thank you again. And last but not least, I think that we all need to go and thank the friends and family that are there all the time for you. If they can stand, and graduates, you've got to stand and give them a hug. So friends and family, stand up. And this is your opportunity to hug them and thank them. Well done, well done, well done. Those were good hugs. They learned well. All right. So today we have a nice but short program for you. I'd like to invite up Professor Sulio Linic, who is the director for the Energy Systems Program, to say a few remarks for all of ISD.
Well, thank you, Diann. Thank you for coming. So I also want to begin by congratulating you and your family members. Maybe another round of applause for our graduates. I also want to congratulate faculty and staff members. There's lots of work that goes into a degree, and they really do an impeccable job, particularly our staff members. They're great support to us and to our students, and I want to congratulate them again on a job well done. So I've been asked to give you a few words of final advice before you depart the University of Michigan here. And when I was thinking about this morning, I was kind of asking myself, whom do I want to direct these words to? And I realized that over the course of your career, you're going to be facing professional ups and downs, like everybody else. So I hope that the words that I'm going to speak in the next few minutes actually speak to that person that is professionally down in your career, and I hope you can use these words to motivate yourself to persevere and to face head-on the challenges that are in front of you. So, like I would argue that you're getting one of the timeliest degrees that the university can offer. You're getting a master's degree in the Integrative Systems Design. And I think you are getting a skill set that is the best suited to respond to the contemporary challenges that we are facing. We live in the most integrated world we've ever had. You're going to compete globally with your peers across the world, not only locally in your local environment. Emerging technologies and novel ideas are actually not emerging anymore in a particular technological or scientific silos, but they're actually emerging at the cross-section of various disciplines. We used to think of a vehicle as basically engine with 4 wheels and 4 seats. Vehicle today is actually a software on 4 wheels, and that software actually talks to the driver, to the people inside the vehicle, and not only that, but it also talks to the outside environment. Solutions in this space require knowledge across the various areas of science and technology. In many of my courses, we talk about global energy challenges and the global pollution problems that we face globally. And the solutions to these problems will require not only solutions in the technology and science space, but also solutions in the area of public policy, economics, law, social science. I would argue that you are well equipped to tackle these contemporary problems. And in fact, when we were designing integrative system design program a few years back, the idea really was this. The idea was to develop what we call the T-shaped person. I think the appropriate word is really a comb-shaped person, a person that is not only specialized in a particular area of science or technology, but a person that can integrate across these various areas of science and technology and bring to the table a unique skill set that is highly valuable, I think, in the today and in the near future. So I think you are really well equipped to solve these problems. Another thing that works in your advantage that I want to emphasize is that you're entering the workforce in what I would argue is the most prosperous time in the history of humankind, and for most of you in the most prosperous country in the history of humankind. And I hope that you really take advantage of it. And to me, that means really reach for the skies. Do not settle. Challenge yourself. Be the best you can be. The next few years are going to be the opportunity to prove to yourself what you can be, to motivate yourself, and to really challenge yourself. And I hope you don't waste that opportunity. Finally, you're leaving University of Michigan today and next few days, but I really want to remind you that this is your second home, and this should always be your second home. So come back to us, send us emails, give us advice, complain to us. You know, we're busy, but whenever I get an email from former student, I actually catch myself smiling about it. It kind of brings a smile to my face. I'm very happy about it, and I'm sure most, if not all, of my colleagues feel that way. So I think it's very important that we keep in touch. It's very important that you bring us ideas, and I can promise you that all of us are here to help you in any way that we can. So with this, I'm going to close. I'm going to congratulate to you and your family once more. And again, thank you for coming and being part of this experience. It's very special for all of us. Thank you again.
I'd like to now introduce Professor Robert Bordley, who's the Program Director for Systems Engineering and Design, and he will be inducting the Sigma Theta Mu.
Sigma Theta Mu! Sigma Theta Mu is the honor society of INCOSE, the International Council of Systems Engineering. And actually, that society was formed by industry demand, by defense contractors who said, we've got all these people who are brilliant. We've got people who are brilliant and specialized in different kinds of areas. But we need to solve problems that cut across specialties. We need systems engineers. And so they created a society to try to get the engineers they needed to meet their demands. You know, systems engineering is very much about going to a customer and trying to translate the problems they have, you know, the holistic needs they have, into technical problems that can be addressed by all these different specialists. Customers don't come and say, I want to have a piston or an engine control module or a bunch of wheels. They want personal transportation, whether it's a car or not. And that's what the system engineer needs to do, to take an understanding of what they truly need and translate that into problems that can be solved by the guy who designs tires, by the guy who works and develops pistons, by the guy who develops engine control modules, and so on. And after it decomposes into those problems, after they've solved the problems, we then organize how it's all put together into a system that solves the customer's problems. That's where system engineers are needed, to put all the pieces together. We need specialists because in this world, you need people to really focus on one thing if they're going to be best in the world at that one thing. But when you have those specialists, those Albert Einsteins, those Thomas Edisons, you're also going to need the systems engineer to put it all together. And that's what systems engineering does. And that's why INCOSE was founded. I like to think that system engineering started in the 20th century, and one of the key players was a fellow named Cy Ramo, who was involved working with DoD. This was the time of the 1950s when the US and Russia had nuclear weapons that could wipe out civilization. It was a time when you needed people to pull together a lot of all these skills. And of course, human civilization survived. That's one of Cy Ramo's legacies. He also went on to found TRW. But what makes him special to us is that one of his early employees, whom he mentored, was a fellow named Don Winter, who would go on to become Secretary of the Navy, President of TRW Aerospace, and a great contributor to space exploration. The Chandra telescope is still out there as a permanent memento to his system engineering skills. And then he came back to Michigan and started the first introductory course and helped found this program. Now, at the time, system engineering was a V. You would basically, the DoD would give defense contractors, their requirements. The contractors would break it down, divvy it up to their suppliers and specialists, and then put it all together. But when Don Winter came here, well, I and Harvey Bell and David Tao and others would say, wait a minute. Our customers don't give us requirements, so you can't just start there. You need to start earlier. And likewise, we can't just give finished products to our customers. We need to worry about their manufacturing. We need to worry about their maintenance, their sustainment, whatever. And so the V translated into, you had a line here and a line here, and hopefully you'll begin seeing that it looks like an M. And that's the Michigan difference. That's what Michigan brings. We bring this evolution of the V that played a big role in the survival of our species, of our civilization back in the 50s. And who knows, it may play a role in the future. It's a scary future as well, to the full M. So systems engineers have this capability of leveraging the expertise of all the specialists. And what does that mean? That means we can create things that are beyond the capability of any one human or of any one group of humans. It's a teamwork of specialist geniuses, along with the system engineer putting their talents together to create truly something that is extraordinary, truly something that is beyond the capability of a human being, or hundreds of human beings, or thousands of human beings. I like to think that there's a name for people who can do the extraordinary: superheroes. And our system engineers, our graduates, are all superheroes. Choosing among superheroes is hard. Sigma Theta Mu is the elite of the elite. But Harvey Bell, David Tao, myself, and others from our selection committee found truly the cream of the crop to honor with membership in Sigma Theta Mu Honor Society. The first person I'd like to call is Sukrut. He worked as a quality engineer, and I like to emphasize quality because quality is defined as conformance to requirements. And system engineering is about requirements management. So very much, quality engineering is very much a part of what we're doing. I'd also like to ask Sarah to come up. Sarah, likewise, was into supplier quality engineering. And I'd like to emphasize the supplier part now, because in systems engineering, who are the specialists? Oftentimes, they're the suppliers. And so system engineering is how you manage and divvy up work to those suppliers. One of the things that I really admire about both Sukrut and Sarah is the fact that Sukrut basically increased the inspection rate by 20%, in his facility, and Sarah increased the throughput rate at 10%. At General Motors, I used to work at trying to increase throughput of plants. In the case of Sarah, you were talking about lines that support the Cadillac and the Camaro, which are pretty profitable lines. You want those input up. So again, I'd like a round of applause for our two superheroes. There you are. Super, I'd like to give you. And Sarah? All right, let's do Sukrut first. Right. Oh, absolutely. Thank you. We see he's our specialist in terms of graphical design and artistry. Not my specialty. Thank you. Wonderful. I noticed that. Remember, I'm a system engineer. I just put things together. And now I'd like to mention another superhero coming from the System Engineering Design program. Jong, I basically had the pleasure of working with, for several terms. He's one of those students that is quiet, but knows an awful lot. It's sort of like when you look at him, you see his mind working. He has a lot of distinctions. One of the interesting things while he was here is he worked on a National Science Foundation proposal. I used to work at NSF, and I know that we don't give out those grant proposals that easily. It's a pretty competitive thing. I remember someone telling me that if you're going to apply for money, NSF may not have a lot of money, but it's the best kind of money to have. Jong Mun also did a crackerjack job on the NDP project. It was unusually challenging, and he was pulling a lot of the pieces together. A very talented individual. He's going into the autonomous vehicle, and as you know, that's one of those projects that, as far as the automotive industry, is really going to make, change the world. Dong, please come up. I imagine this is going to be the least of the honors that is given to you at some point in time. But I'd like to think at some future point in time, when you, Basara, are all famous, and I'm sitting in my wheelchair or my old folks home or whatever, I'll be sort of telling stories and they'll say, oh, come on, you didn't know him. Yeah, I really did. So thank you. It's been a privilege to know you. Now, one of the things that I'm personally privileged to is to have a new leader, Diann Brei, who's taken a deep interest, in learning about all the specialties that she's responsible for. She went with us, me and Art Hyde, to a conference in Indiana. Sorry. English is my first language. So again, she very much was supportive, even though she originally wasn't familiar with that program. And as a result, when we proposed making her a member of Sigma Theta Mu, the board was unanimous. You've got to make her a member. And so with that, I am proud to recognize my leader and give her membership in Sigma Theta Mu. Diann.
I get this too? Awesome.
You get this too.
Thank you.
And actually, I'm the treasurer of the society, but the president used to tell me that he always gets really moved when he sees people wearing the pin. So,
Thank
so
you.
when you see Mike Benarsic, please wear the pin.
Okay, I will. Thank you, Bob.
Thank you.
And thank you for all your remarks. This was a surprise, so thank you. So, in closing, I have some words for the graduates. As you embark on your next journey, we have prepared you well to be leaders and best. We expect you to go out there and to lead, to tackle the world's problems and make an impact on the world. So go, be bold, go, be daring, and last of all, go blue.